Alright guys, I am going to help you get through lesson 9.4. This lesson is on the changing dimensions and how it affects the perimeter of a shape versus how it affects the area of a shape. So I'm going to explain this in the video, but it's kind of hard to explain in the video and rather than in person. So we're going to go over the key concepts. So on this page we're focusing on how does changing the dimensions, remember the dimensions are the side lengths, affect the perimeter. And you got to remember, perimeter is when you add up all the sides to get the total distance around that shape. So we'll go through the words here, and then I will write down a rule that I have on the side. It says, if the dimensions of a polygon are multiplied by x, then the perimeter of the polygon changes by a factor of x. So here's what that means. If you go from triangle 1 and triangle 2, if you look at these dimensions, 3, 3, and 2, they were all multiplied by 2, 6, 6, and 4. So what that means, basically, whatever you do to the dimensions, you'll do the same thing to the perimeter. So if the dimensions were multiplied by 2, the perimeter of this, which 3 plus 3 is 6 plus 2 is 8, will also be multiplied by 2. So the perimeter of figure 2 should be 16. And if I add these up, 6 plus 6 is 12, plus 4 is 16. So we're going to write this rule down. It's kind of hard to explain, but you might want to pause the video after I talk through this to get it written down. So the rule for perimeter is whatever happens to the dimensions, do the same thing to the perimeter. So take a second, you might want to pause the video, get that whole rule written down because it's important. When you're done writing it down, press play and continue. Okay. So I'm going to try to explain this a little more. Whatever you do to the dimensions, you do the same thing to the perimeter. So if you have a square and you multiply all of the dimensions by 5, the perimeter of that square will also be multiplied by 5. It's always the same exact thing. If you divide the side lengths of a rectangle by 4, the perimeter of that rectangle will also be divided by 4. All right? So let's go down and show you how this works in an example. Now, I'm going to get my highlighter ready here. It says, suppose the side lengths of the parallelogram at the right are tripled. What effect would this have on the perimeter? Justify your answer. So, here's what the rule says. If I multiply these dimensions by 3, and notice this, 4 times 3 is 12, 3 times 3 is 9. That means the perimeter of this parallelogram should also be multiplied by 3 to get the new perimeter. So when you're doing this, here's kind of what you would do. You would start out with finding the perimeter of this parallelogram. And if this bottom is 4, the top is 4. If the right is 3, the left is 3, I'm sorry. And you would find the perimeter. Remember, perimeter is add up all the sides. So if I add them up, 4 plus 4 is 8, 9, 10, 11, 12, 13, 14. The perimeter is 14. Now, according to this rule, if I triple all the dimensions, then the new perimeter, I should triple this 14 as well. That means I can make a prediction that the perimeter of this parallelogram will be 14 times 3, which is 42. So I'm actually going to write that down here. Perimeter is 42 question mark. Now I'm going to go through and prove it because it asks us to justify your answer. And I'll show you how this looks in a second. If the bottom is 12, the top is 12. If the right is 9, the left is 9. And if I add these up, 12 plus 12 plus 9 plus 9, they add up to 42. Okay? So this rule is a way to make predictions. All right, now, just as far as to see how you justify it. So what effect would this have on the perimeter? Justify your answer. So here is, I'll circle it in red, what effect would this have on the perimeter? The perimeter is 3 times greater than the perimeter of the regular figure. So that's that part. Justify your answer? Well, kind of what I did on the right. I found the perimeter, and I predicted that 14 times 3 would be 42, and then I proved it. I added up 9 plus 9 plus 12 plus 9 is 42. So that's kind of what they're doing here. They said the original perimeter is 14. The new perimeter should be 42. It's kind of, we'll show you in problem A, because we'll do that one together. Now, in problem A, let me get this set up here. It says, suppose the side lengths of the trapezoid at the right are multiplied by 1/2. What effect would this have on the perimeter? Justify your answer. Well, first off, what effect would it have? If you multiply the dimensions by half, you're going to multiply the perimeter by half. You always do the same thing. So we're going to start out by writing that down as a sentence. Okay? You will multiply the perimeter by half. Because it's the same thing we do to the dimensions. But now we're going to have to prove it. So the first thing I'm going to do here is I'm going to find the perimeter of this trapezoid. Remember, the perimeter means add up all of the sides. So, and you could use a calculator. So if I add 14 plus 14, I get 28, plus 24, I get 52. 52 plus 13 is 65. So in step 1, I would just write, let me make this a little bigger, original perimeter, I might write original P equals 65. Okay. Now, if I were to do a new one, basically my new perimeter should be half, if we multiply 65 times half. So if you type in 65 times half into your calculator, we should get the new perimeter. So I'm going to write new, and perimeter should be half of 65 should be 32.5. Now that's our prediction based on this rule. Now to prove that, to justify that, I'm actually going to do that math, which you'll see in a second. Now first thing, I'm going to go up to my trapezoid, and I'm going to multiply each dimension by half. Remember, you could do this with a calculator or mental math. So some of these are easy for mental math. So for example, 14, half of that is 7. This, half of that is 7. Half of 24 is 12. And half of 13 is 6.5. And then all I would have to do is add those numbers up. So if I add up 12 plus 7 plus 7 plus 6.5. Okay, guess what I'm going to get? I'm going to get 32.5 centimeters. So this is kind of, sometimes it confuses people what to do. So, but if you write this down, it kind of gives you a format for when you're doing the problems on your own. So you got to tell us what's going to happen. Remember, it's the same thing that you did to the dimensions. Multiply them by half, multiply the perimeter by half. Then show us the work. Give us the original perimeter. Then make a prediction. 65 times half was 32.5. Then prove that prediction. Go through and multiply each dimension by half and add those numbers up and show me that you get the same thing that you got in step 2. That is what this lesson's all about. Now, if you're a little bit confused with that, guess what? I'm going to make you confused on the next page as we talk about area. So, now, I have a rule written here for area. Now, remember, area is different from perimeter. Perimeter is what happens to the outside. Area is the square units on the inside. And it has a different effect than perimeter does. So we'll go through these rules here, and then we'll show you what the heck they're talking about. So first off, in book words, if the dimensions of a polygon are multiplied by x, then the area of the polygon changes by x squared. Okay? Now, I'm going to have you write down the rule over here. Remember, you can pause the video in a second, but let me talk about it first. So here's what it says. Whatever happens to the dimensions, do the blank to the area. Now, it's not like perimeter. We're not going to do the same exact thing. It's almost, but one little thing's different. So here's what I want you to write down. So whatever happens to dimensions, you do the same thing squared. To the area. Now, I want you to pause the video, get this rule written down, and when you're done, start it up, and I'm going to show you how this works. Okay, so let's see what you got. Now, I'll show you up here in the model underneath the key concept. So going from figure A to figure B, I notice that my dimensions are multiplied by 2. So 5 times 2 is 10. 4 times 2 is 8. So the area of the original one, 5 times 4 is 20. Now, here's what the rule means. Whatever happens to the dimensions, you do the same thing squared to the area. So if we multiply the dimensions by 2, that means if we multiply the area by the same thing squared, or 2 squared, we should get our new area. Now, 2 squared is 4, so 20 times 4 is 80. That means our new area should be 80. And if you test it out, 10 times 8 is 80. So mainly, this rule is almost like the perimeter area, except you have to remember it's the same thing squared. That's the big difference. Now, how do I remember that? Well, you know how we say area is always square units? Well, that's how I remember that it's the same thing squared, because area is square units. Now, I'm going to show you an example 2, and then we'll kind of do B together a little bit. So stick with me. If you're a little bit confused, don't stress out. So example 2 says, the side lengths of a triangle at the right are multiplied by 5. What effect would this have on the area? Justify your answer. Remember the rule. Whatever you do the dimensions, you do the same thing squared to the area. So I'm going to start by writing that out, because it says, what effect would this have on the area? So here I would write, and you don't have to write this down if you're watching, but you can if it helps you. The area will be multiplied by 5 squared. Now remember, 5 squared is 25, so that means we're going to be multiplying the area by 25. So now, let us justify the answer. First thing I'm going to do is I'm going to find the area of this original triangle. And remember, to find the area of a triangle, it's half times base times height. So I'm just going to write that here. Half times the base is 2 times the height is 1. And you could type that in or do a little bit of mental math. Half times 2 is 1, 1 times 1 is 1. So the area of this triangle should be 1. Now I'm going to write that down here. I'm going to write down original, and I'm going to write A equals 1 square centimeter. Okay, now let's make a prediction. So remember what the rule says. If you multiply the dimensions by 5, that means we should multiply this area by 5 squared. So for our prediction, we would do 1 times 5 squared. Now remember, 5 squared equals 25. So what's 1 times 25? It's 25. So our new area should be area equals 25 square centimeters. So that's our prediction. Now the last, we have to prove it. So let's take a look at our new triangle here. Remember, the 1 for the height became 5. Remember, 1 times 5. The base, we multiplied 5 to get 10. Now, if I find the area of this triangle, I bet I get 25. Remember, it's half times the base times the height. And, oops, I'm sorry. What did I write down wrong? Okay, so half, I have the height here, and the base is 10. Okay, now you can type that in your calculator or do it mental math. I know half of 10 is 5. 5 times 5 is 25. Holy smokes, our prediction worked. The new area is 25 square centimeters. So I'm just going to show that here. 1/2 times 5 times 10 equals 25. All right, so that's how this rule works. Remember, perimeter, what you do to the dimensions, same thing to the perimeter. Area, what you do to the dimensions, same thing squared for your new area. So let's go down, and I'm going to kind of set you up for this one. And I'm going to have you pause in between to write down what you think. So the question says, a rectangle measures 2 feet by 4 feet. Now, I'm actually going to draw that because I need to see that. And I should turn on the pen first. So I have a rectangle. It's 2 feet by 4 feet. Okay. Now it says, suppose the side lengths are multiplied by 2.5. So the side lengths are multiplied by 2.5. And it says, what effect would this have on the area? Now what I want you to do is I want you to write down this part like right here in words. Remember, as a model, in the example, this is where I wrote down my effect. The area would be multiplied by 5 squared. Now this is a different problem. So write down, pause the video, write down what you think the effect will be, and then restart the video and we'll see if you got that part right. Okay, pause it now. All right, so you should have written this, and it could be in slightly different words. Remember, if we multiply the lengths by 2.5, we'll do the same thing squared to the area. So I would just say, you will multiply the area by 2.5 squared. So that's our prediction. Now, step 2 says justify your answer. So here's what we're going to do first. First thing, you are going to find the old or the original area. Remember, it's a rectangle, so you just need to do length times width. Then you are going to use this rule here to make your prediction and come up with the new area. Last, we're actually going to we're going to actually do the math with the new rectangle to see if our prediction was right. So let's start with the old area. The first thing I want you to do is find the area of this original rectangle and write that down here. So you could pause it and do it or restart, or I'll wait a second too. All right, so the old area of the rectangle, just length times width, is 2 times 4 is 8. So it's 8 square feet. Okay, that's our old area. Now, according to our prediction, to find the new area, we're going to multiply that 8 by 2.5 squared. So I want you to do that. Type in 8 times 2.5 squared and see what you get. Okay, so this is what you should have done. You should have taken the old area, which is 8, and multiplied it by 2.5 squared. And if you do that, you get 50 square feet. Now, to justify it or to prove it, we're actually going to find the area of our new rectangle. So here's what we're going to do. You know the area of the new rectangle is length times width. So what you've got to do for the length times width is you need to take the 2 and multiply it by 2.5 to come up with the new length. Then take the 4 times 2.5 and come up with the new width. Then, length times width, you should get 50 if you do this right. So I want you to pause it. Remember, multiply each dimension by 2.5 to get our new dimensions. And you know what I might even do? I might even draw a new rectangle so I know I can write my new dimensions down. So see if you can do this and get 50. Now try it. Pause the video. When you're done, get started. All right, so here's what you should have done. First thing, you should have done 2 times 2.5. And if you do that, you get 5. And I'm going to put that over there. Then you should have taken the 4 and multiplied it by 2.5 as well. And if you do that, you should get 10. And these are the new dimensions. Now remember, we said if you multiply the dimensions by 2.5, we multiply the area by 2.5 squared. So we should get 50. So we just put that in. We should have 5 times 10 equals 50. And so we just proved that this rule works. Okay. Finally, we're going to go on and we're going to show you example 3, and then I'll tell you what to do next. So in example 3, this is more of a real world example with a lovely stop sign. It says, suppose a stop sign is in the shape of a regular octagon. Sign A, shown at the right, has an area of 309 square inches. What is the area of sign B? Now, this is where, so you guys don't know the formula for area of an octagon. That is not 6th grade math. So you can't figure out the area without knowing our rule. So remember what the rule says. This is messing with area. Whatever we do to our dimensions, so to go from 8 to 12, we are going to do the same thing squared to the area. Now, they give us the area of sign A is 309 square inches. So, I know if I multiply that by something squared, I should get my new area. Now, but here's the tricky part. We have to figure out what they did to 8 to get to 12. Now, I know 8 times 1 is 8, and 8 times 2 is 16. So 8 times 12 must be in the middle. That means they multiplied 8 times 1.5 to get the dimensions. Now, again, remember the rule for area. Whatever we do to the dimensions, times 1.5, we do the same thing squared to the area. So that should be times 1.5 squared. So all we would have to do to find the area of the new stop sign is multiply 309 times 1.5 squared. And if you do that, you'll get, they actually have the answer for us down here, 695.25 square inches. So, oops, I keep doing it right with the highlighter, 695.25 square inches. So that's where the rule comes in handy. We don't know the formula for area of an octagon, so there's no way we could do this with the 12 with that knowledge. But we do know if this times 1.5 is 12, 309 times 1.5 squared will get us our new area, and it did. All right, so your job is to do whatever you still have to do for your makeup work. Hopefully going over those problems helped a little bit. I know it's tricky, but we'll keep working on it. Thanks, guys.